Every object has actually an outside and an inside. One of the easiest way to find this is actually when we go into edit mode and then we go to mesh display and turn on normals. And let's scale this one down a little bit, and there you see actually the normal. So what is the normal? The normal basically defines the outside of a surface. So what does outside and inside basically mean? So for example, let's create a circle and then scale it down. E and Z, let's move it up. E and Z and scale, E and Z. So now there we have a small object. And let's shade this one smooth. Maybe let's give this subdivision surface modifier so it's nice and round. Okay, perfect. So you can actually see that the outside is slightly bluish and the inside is more silver color, which means by the color already I can see that my object is inverted. If I select the complete object and turn normals on, you will see they all face to the inside. If, for example, I select the lower ring and fill it and the upper ring and fill it, what I have now is not kind of like a volume in the center, but the inside is actually hollow. So if you would send this to, let's say, a 3D printer like a Z-Core, what could happen is it will print you everything around it as a mold because you told it this is the inside surface and the volume inside this vessel actually will be hollow because that's an outside surface. So how do you, for example, fix this? This is actually very, very easy to do. So to double check if something is inverted or not, you can always turn on the normals and then you can go to UV and shading and say, for example, recalculate, because the normals should always face the outside. And we can also flip them, for example. And if, for example, you have individual faces that are flipped, you might see artifacts like this. Because here the software is kind of confused because some faces are looking to the outside, some faces are looking to the inside. So there we can select everything and simply say recalculate, and in case it is an individual, simply flip it. So how do you prevent that maybe from the start the normals are inverted? Honestly, what I do most of the time is simply when I create an object and, for example, extrude it up. Let's say I create a surface now there and E and Z there. I select it and then press Ctrl N just by default to always make sure that the surfaces are created the way they should be. So for example, here in this case, E and Z, let's scale this one in, and E and Z, E and S, AA, Control N, and you see now actually Blender understood, oh, I start to create kind of like a vessel. So before it flipped it to the wrong direction, but now actually you see all these faces are facing to the outside, so the normals are adjusted correctly. So where are these normals very useful or important for? So let's do something like this, and let's maybe scale this one up, and let's add a plane, and I rotate this plane, and let's turn on this, or 1 meter, so we can see actually the line nicely. So you see actually where the face of the normal goes to, so upper left corner. And I will tell Blender here, give a Boolean modifier, difference, and this plane. And you see now that wherever the normal looks to, that part of the mesh it keeps, and the rest of the mesh is discarded. If I, for example, flip the mesh, so the normal, the other part will remain. If, for example, I have two objects and here, not two objects, three faces, and here one face I will flip. So I'm not sure what Blender will do, but maybe there should be kind of like, yeah, it can't really execute the Boolean operation because I tell the software kind of like, well, keep this and keep this, but cut this and cut this. And this is not really logical. No software can do it, which is why when you do Boolean operations, it's very important that your normals are all unified. However, actually, the rotation of the normal can be very helpful to create kind of like multiple cuts or separations at the same time. So let's say Shift D, I move this one up and I leave edit mode, and we see that based on the top mesh, this area got removed because the normals face to here. But then we have this second mesh that says, well, remove this and keep this, but that, as you can see, doesn't work. Honestly, also doesn't make sense because then just have it this way. But if, for example, we keep this and then this face we flip, so we have, for example, something like this, you will see it slices out a piece in the inside because the normals face to the top and the bottom, and the inside is defined as being shaved away. So that actually works really, really well. So you see, with one Boolean command, I can slice a piece out. And again, when we do Alt D, escape, and then, for example, flip the result by going to intersect, you see now there actually we have the intersecting volume. So this is actually kind of like how modifiers, not modifiers, how the normals affect, for example, the Boolean modifier. It's very, very important because it basically defines the direction of what is being removed and what will be kept. But there are other cases, for example, that are important to understand. So let's say I make a copy, Shift D there, I'll move this one up, and say U Boolean union this one and this cube. I actually make this one wire so we can better see it. I will go in and say flip the direction of my normals, and you will see, oh, this is actually what the end result is. So what happened here? Well, the main problem that happened is we have an object that defines a volume in the inside. But this object, for example, because the faces are flipped, the volume is in the outside. These are the inside faces, so what's actually inside the cube is hollow. And that is why, for example, you get this incorrect Boolean result. So if, for example, we select one face and say flip, well, it doesn't really do anything. We really have to adjust everything so we get the correct result. And again, now with a surface, it shows up and down, and with a closed volume or object, it shows the inside and outside. And it's kind of like what the normally is for, outside and inside, up and down. It's pretty much the same. A different thing also to keep in mind is, let's say we make a cylinder and I would like to project onto that cylinder a small plane. So there and there, okay. And let's move this plane to there and there, so it looks straight at it. Okay, good. So this plane I would like to project onto this object. And I can go to local to, for example, see how this object is rotated. There you see, for example, where positive y is, positive x, and positive z. So we can add shrink wrap to this object along positive y. If I say along negative y, nothing happens. Okay, so let's say I select everything and say flip the normals. So you see now actually the normals look this way. And let's see what happens. Positive and negative. So you see in this case actually it doesn't really matter what type of face normal you have, because the shrink wrap in this case works actually based on the object, not necessarily really on the face normal. So if, for example, we select only few faces here and say flip there, it still projects it perfectly, but you see then the mesh here is not really correct. But this is actually very important when, for example, we would like to do an instance on this object. So, for example, where this object is, so cursor to select it. Let's make a small cube. There, and there. And here this I extrude out a little bit so we can easily see how something will look. And parent, and then please do a face. Yeah, okay, good. And you can clearly see the different results, how based on the way how the face looks, this instance result changes actually the orientation, how this object will be instanced over the surface, because the instance command uses the face normals. So if we simplify them all this way, so they're all unified, or for example flip them, and obviously we want it this way. So because the instancing works along the face normal, and you see that this object is positioned and rotated along the face normal. And before, those faces which are inverted, like this and this, there it simply malfunctions. So that's kind of like where, for example, you want to make sure that the normals for the instancing are unified and facing into the correct direction. For shrink wrap it doesn't necessarily matter, but then for the dupli faces it does.